All right, welcome back to Intro to Statistics. We are going to talk a little bit today about binomial distribution. Okay, this is the subject of chapter 6.2. Okay, there's a couple of things we got to do some checks for before we start in on doing this. And usually the problems are pitched to you in a way that these conditions are fulfilled, especially when they want you to practice the algorithm for doing this. Okay. So the things that we have to do, binomial, this means there are two possibilities. Okay, there are two possible outcomes. Okay, true, false, heads or tails. We don't worry about like, well, what if it lands on the side? We don't allow that possibility. Okay, if you have true or false, you're not picking like, well, it's either true or it's false. We're not thinking, well, sort of like any kind of gray area or fuzziness. We are not entertaining that idea. Okay, so we do boy, girl, we do heads, tails, yes, no. Okay, true, false. Okay, binomial pretty much restricted to there are two possible outcomes and they do not overlap. Okay, so I know boy, girl, that's a little bit more complicated now, but that's okay. Heads or tails, you could still like flip your coin and have it land on the curve and have your coin be something like this. Well, which one is it now? We're not entertaining this possibility. Okay, it's got to land on a flat surface. It's got to be heads or tails. It's not going to be like, well, maybe it's a little bit of both. Nope. Binomial distribution, we are not, this is a fairly straightforward and very simplistic view of the universe. It's yes or no. It's not, well, it's sort of like, nope, yes or no. So it's a very, very restricted sort of set of outcomes. Okay, so the first thing you're going to do is like, should I use binomial distribution on this? Do you have a yes or no outcome, boy or girl, heads or tails? So we have two and only two outcomes. Okay, later on, there's a distribution called the trinomial distribution. You have three outcomes. Okay, there's lots of distributions that do more of this, but binomial, we have two and only two outcomes only. Okay, they are given a certain number of trials. They specify number of trials, and its number of trials. Okay, so they're going to tell you, like, we have 8 airplanes. We're going to see if they're on time. We have 22 airplanes to see if they're on time. You're not going to be allowed to say, well, we're going to do, we're going to do best, we're going to do 5 out of 7. Oh, I didn't like the result. We're going to do, 7 out of 13 or something. Like, you're not allowed to change the number of trials as we go through the problem. Okay, they set, like, we are going to ask 26th graders, have you ever tried tobacco? He's like, well, 3 more showed up. We're at 23 now. Like, nope, you get 20. You set the number of trials in stone first. That's where we're going to go. Okay, so you have to be careful. Number of trials is set. Okay, so we have a set number of trials. Okay, in the face-to-face class, a lot of times I'll hold up my key ring and I'll say, I'm going to start trying my keys until I get in. Like, well, this means that we're going to check the keys until they open the front door. If I've got 10 keys, we're going to try them all. It doesn't matter if they got in on the second one. Like, you can't change the number of trials when you started. You said you're going to check them all. We're going to check them all. We're going to check 10 keys. Okay, that's it. And if you don't make it into the house after 10 keys, you can't say, well, we've got another key ring. Like, nope, you get 10 trials. That's the rule. Okay, so binomial distribution, there's 2 outcomes. Okay, you either got into the door or you didn't. And we have a set number of trials. We have 10 keys that we're going to try, no more, no less. Okay, the probability of success. Okay, we use probability of success. Okay, that's even though that's not always a success. If I want to try and say, okay, I'm going to interview 10 6th graders to see if they've tried tobacco, and like they say yes, like that's not really the way any measure. That's not a success. Okay, we're not looking for like, yay, 6th graders tried tobacco. Like, no, that's bad. Okay, but we're going to use success. Okay, but we were doing. I remember one summertime I was teaching this to a group, and we were doing this problem, and I said probability of having a boy. And I said that's your success. Since most of the class was women, they were not happy. Okay, but I don't mean like having a girl as a as a child is not a success. It's just that's how we're defining it for this particular problem. Okay, so success, that's the outcome that you're looking for. Okay, again, sixth graders trying tobacco, not a success, but that's what we're looking for this particular experiment. That's what we're calling a success. Okay, and it's going to be constant. Okay, so if you ask a bunch of sixth graders and try tobacco and the first three say yes, what do you think the rest of them are going to say? They're all going to say yes, because that's how sixth graders work. Okay, so you have to ask them confidentially so that their probability of success, the probabilities aren't influenced by each other. So these also have to be independent. Okay, if I ask people online in a grocery store and there's 10 people online and the first two are taking longer than 10 minutes to get their stuff out, the other 8 people in line, they're also going to take longer than 10 minutes to wait in line because they got to wait for the people in front of them. That is not independent. Okay, so we're talking about these probabilities. They have to be independent. Okay, we have a fixed number of trials. Okay, probability of success is not changing as we go through the problem. Okay, the probability just stays constant, so that's a constant. Okay, again, if I'm going to use my key ring to get into the house, after every failure, the chance that the next key is going to open that door, assuming I've got the right keys to the house, that's going to start going up. Okay, so that's not a binomial distribution because the chances of success opening the door, that is it's changing as I go through the problem. So the probability has to be constant, they have to be independent. We have a set number of trials and we only have 2 outcomes. Okay, so I know it's not a realistic situation for a lot of times, but for a lot of things we do model as binomial distribution. I worked for government, where I worked for a defense contractor. We wanted to set up a bunch of satellites to see if our telecommunication satellites were going to go. A group of satellites is called a constellation. I thought that was kind of cute. And all they want to know is, like, is this satellite still working after 10 years? Yes or no? Okay, like how many satellites did we put up? 10. So we have 10 experiments. Are they working after 10 years? Yes or no? Okay, will this bounce a cell phone signal, or this bounce a signal out after 10 years? Yes or no? So in that case, yeah, it worked out pretty well. And the satellites aren't interacting with each other. They're not changing. Each satellite is built, it's set up there. So it's not like they're going to be influencing each other. So the probability of success is independent. Okay, and then we have 10 of them. And like, did we get a signal or not? Yes or no? So did it work or not? So there's a lot of things that we can use for binomial distribution, but understand that we did take a simplistic model of the universe in order to do this, and these are the assumptions that we are making. So just to recap, 2 possibilities, yes or no, boy, girl, true, false, heads, tails, okay, something like that. And then we have a set number of trials. Okay, we're going to look at a family with 4 children. We're going to try 10 keys to get into the house. We're going to look at 10 satellites. Okay, whatever. Probability of success is going to be constant. So I know that you talk to women, or talk to families trying to get specific genders of children. Hormones change the mother's body. It's going to be more likely that we're going to have boys, or more likely we're going to have girls, depending on how many children that she's had, of what type they've had. So all of this can change. So it's a simplistic model of the universe. We're just going to assume that the probability is going to remain constant. Okay, so those are your conditions for being able to use binomial distribution. Now, just a little bit longer, I'm sorry, TI 83. Okay, this is where you're going to be happy you spent the money on a TI 84. Okay, TI 83, you got to remember, it's n times the probability, and then this is the number of successes that you want. So it's NPX. So we're going to do binom PDF. Okay, I'll show you where that is. Okay, we're going to go to distributions. So second function, distribution, and we're going to be using binomial. Let's go down a little bit to binomial. We're going to say PDF or CDF. We will show you that in the next section. next part when we start doing some problems, and notice that they just have a parentheses here. It's always N, P, and X. Now, if you bought a TI-84, you have access to a TI-84, when you type this number in, when you press this in, it will guide you through N, P, or X. Okay, it will ask you and prompt you which ones you want. So if you have a TI-83, you're kind of stuck remembering this. If you have a TI-84, it will prompt you as to which one you want to use. So regardless of which one you want, I would definitely go practice, go to the library, check one of these things out, practice your homework by using this thing, and make sure that you're pressing in the right buttons with the right numbers to get the answers that you're supposed to get. If you are used to a TI-84 and you only have access to a TI-83, make sure you practice with it. If you have a TI-83, you might want to check out TI-84 to see what they do. Then we might have a preference. But if you don't have a choice and you have to remember this, you're going to have to remember how to do which order they're going to want this in. Okay, so that's something that you're going to have to be accountable for. Okay, so I urge you, practice on the tool you're going to use to take your quizzes with, because you're going to have to remember this on your own. Okay, so thank you very much for tuning in, and I will see you in the next video. We do some examples. Thank you.